All right, so we're all set here. Now for today's session, if you've noticed, everybody's been muted, so that way the recording can be as clear as possible. And we'll send a link to everybody here, probably by tomorrow, with a link to the recording. And anybody else who's registered will also get a link to this session too. While we have today's session going on, if you do have any questions, please use the questions tab, and I will take your questions. If I can answer them, I will, but most likely I would have to ask our specialist today. And a little background about Madhura. Madhura has graduated from University of Cincinnati with her master's degree. She's been with Altair over 2 years being a CFD specialist, working with development and our product management team about doing CFD with our products. And so she's well versed in today's software and the topics. So I think you'll really enjoy what she has to say. When she's done, I'll go over a few other points about how to get sponsorship for any competitive team, how to get a student version, plus the training materials we do have online, and talk about that a little bit. And also for any of the Formula SAE teams that are in attendance today, I'll give a brief description about our Bill Adam Award that we'll be having at the Formula SAE event coming up in May at Brooklyn, Michigan. So without delaying Madhura any longer, I'm going to make her the presenter so she can start.
Okay, so my name is Madhura, and I have been, as Darius said, working in Altair, mostly doing all the CFD work, and I have been here for 2 years now. And I'll start right away with the presentation. So, Darius? Okay. So this is a short agenda over here. I'll go over some of the critical aspects of domain, or how about the dimensions of the domain, how to set up the case, and what things you need to take care of beforehand. I'll cover that for about 20 minutes, and then I'll go directly into a live demo where I'll show you actually how to set up a case in virtual wind tunnel, and how you can also do minor morphing, like design changes, again get it back into virtual wind tunnel, and then do the optimization kind of studies. And then I also have some of the videos, like eye candy videos, to show you about multiphysics, mainly like FSI or acoustics kind of studies. But it's like too much of information if I have to explain you everything. So right now I'm just going to have eye candy videos to show you. So why do we do external aerodynamics? Mostly, like for a lot of things depend on the outer shape of the car, its performance, fuel economy, how much can be the maximum speed of your car, acceleration of the car, and then for the cooling of engine, transmission, all these are really important components. They need to be cooled. Then also, if you think of comfort of the driver in the cars, you need a good HVAC, especially if you're sitting in Arizona in the month of July. Then you need to have a good HVAC, and the air which is blowing over the car is the same air which is going to be going to ultimately used for your HVAC. So it needs to be channeled or guided in a proper way, so that you have effective cooling or heating, whatever. Then there's also, if in the rain, how the wipers operate and how the dirt accumulates around along with the airflow, how the droplets travel over your windshield. All these things are influenced by the airflow around the car. And there is also stability of the car. If there is, a sudden gust of wind, or there is a large like in Michigan, we really have a lot of truck traffic, and I can feel sometimes if the big semis are moving besides me or passing besides me, I can, you feel that kind of a cross wind sensitivity. So so if we look from F1 car racing point of view, then they are mainly concerned about two things. One is the downforce. So there has to be a proper or enough force to keep to push your car downwards and have all the energy onto the car speed. Um, so that has to be maintained to get your performance. And then there's also a drag force. Drag is basically depends on a lot of things in the car design. So it is ultimately a resistance to the car. So it has to be reduced as much as possible. And then there are things like multiphysics. For example, the spoiler over here at the rear end, if it is flapping and flutter and starts vibrating, and if at all that frequency it matches with the natural frequency, all of your car is going to vibrate very badly, and you really don't want that. So FSI is fluid structure interaction, and this is one important areas of research in F1 cars. Or there is also aeroacoustics, because the wind which blows over the car, it generates some eddies, and those eddies, they're traveling from the side of the car, which is very much at the same height as your ears. So if they create or generate any noise, it's really going to be uncomfortable for the drivers. So even that becomes a part of multiphysics. This diagram at the top, it's the three things we are really concerned of: drag, lift, and side current because of the wind sensitivity. Now, the lift is actually a force in the upward direction, which is not required, but which is what is generated in the car systems. But we actually want a downward force, but the lift is the upward force, and we don't want that. So lift, drag, and the side current are the three forces to avoid. Now, what happens is most of the times drag is the main contributor to all of these three resistances. It's almost about 75% of the resistance. And since long times, they have always tried to reduce this drag, and you can see this red belt over here, how the drag reduced for the cars. And you can see, like, currently for last several years, average drag has been around 0.3. And then there were some cars which really had very low CD, like over here, Tatra had something like 0.22. But I think so yeah, it mainly depends. And so yeah, so car companies can really reduce that drag. And just to give you some, has really very good value of drag. It's just 0.03, and Eiffel Tower has somewhere from 1.8 and 2. And humans in upright position can have anywhere between 1 to 1.3. how they design the upper body, which is actually the face of the car, and then the technicians and the designers, they have to come at some compromise point where it looks good as well as it performs well. So that's always a challenge. Then Tesla in, again, Germany did this study of designing better rims for the car, and they tried to reduce this drag just for the wheels by 0.03, which doesn't really seem a significant number, but then if you compare it with the total drag, which is 0.3, this reduction is about 10%, so it does matter. And then designing the rim, you also have to remember that the rim not only it has a drag, but it also helps in cooling the brakes. So you cannot neglect that fact while designing a very important aspect of rim design. Moving on to virtual wind tunnel, there are the cars are actually when tested in wind tunnel. There are different kinds of wind tunnels. So this one is one of the wind tunnels in Netherlands, I guess. And this green colored diagram over here, it shows that this is the complete overview of the wind tunnel. This is a big fan over here, which is, you can see it's really big. And then the wind blows over all the section, and then this area is where the cars are placed and tested. So there are different kinds of test sections, like open test section over here, and then for the closed test section, all these walls are placed very close to the car. Then there's also, in some test areas, there are rolling belts. So there are like 4 rolling belts for the 4 cars, so it's like simulated as if the car is running, and but the wheels are actually like held together with struts, so the car doesn't roll, and only the belts are made to turn, so it's like turning in place. And the belt which is in between, it simulates the flow beneath the car. So yeah, different kinds of testing, and then there are always all these sensors around which will, calculate the drag and various different things in the test area. Also, there are the cars, they can be tested in full scale or scaled down models. So one of the good things in full scale is they are made of clay models and on a wooden frame. And what they do is, you can see this man over here, he has a smoke gun, and he blows that over the full-scale model, and he can actually see how the flow goes over the car and how the eddies or how it behaves in the wake area. Next is the preparation for a CFD run. So preparation is it's the first and a very basic or very important step in all your computational study. All your results, they depend on how well you really do prepare your models, and so do take time in preparing your model. It does take up to 4 weeks for cleaning, having surface mesh, which so surface mesh can make up to like 7 million as the element count. And in the cleanup of the geometry, there are a lot of things you can take care of. Like when you get the CAD models, especially in the commercial setup, we always get models which are like 10 gigabyte. Like they have like huge size. That's the size of just a CAD file which we get sometimes from the customers. And then I have to clean it up a lot. Like, I don't really need all the nuts and bolts in the car. I just need the parts which are in direct contact with the flow. So I try to eliminate and try to reduce my model and then connect it well and then surface mesh it. So those things are, they do take a lot of time, and they are boring at sometimes, but they are really important. And then the volume mesh, it goes up to 70 or anywhere from 70 to 150 million. Shouldn't take as much time for the volume mesh if you have prepared your model well. Then in CFD, there is also something called boundary layers. These are the mesh layers which are close to all the car parts, mainly to capture the wall gradients or the wall gradients from the car to the outer domain. And these boundary layers can be as small as 1e minus 4 meters. And then on the car surface mesh, like on the actual car, you can have mesh size somewhere between 2 to 10 millimeters. And it depends actually on the how much of the details you want to capture on the car, or if you have some extra details on like the rear side of the car, some special wings, then you might need even smaller mesh size over there. For CFD run, it can, if you are running a transient run, it's always good to run a transient, because the process in life is actually transient. So it can take about 2 or 3 days to run the transient model. Again, depends on how many cores you are using. And in that, I'll say it's usually simulated for physical time of somewhere like 3 to 4 seconds, but it is going to take more than 2 days to get the results. Or if you just want a rough idea of how the things are going to be, then you can just run a steady state run, which can be just overnight, definitely less than a day. So it gives you a better idea, or not like a rough idea. Of course, transient results will give you always better accuracy, but you can have steady state run to start with. And then when you have all this simulation ready, you have a lot of data to post-process. So you need good machines, not only to run your case, but also to handle all this data, because again, there can be, you may have requested a solution on different surfaces, cut sections, or different points, and it really becomes the sizes become really huge. A few of the modeling aspects, I think, so constructing a wind tunnel in a simulation, it's always good to have 3 car lengths of distance in front of the car, and about 7 or even more car lengths at the rear end of the car. And then, so the blockage here ideally should be like 2%, and this blockage, what I mean by that is the ratio of the inflow area to the car frontal area. That has to be only 2%. So that is like a rough idea of how big the wind tunnel should be. Surface mesh, so for any of the VWT or AccuSolve run, I usually have tria elements over the surface, and then my size, as I said before, it varies somewhere from 2 to 10 millimeters. And then the volume mesh size, for the volume mesh, so this over here is not actually a wind tunnel. These are the refinement zones I have built outside the car, but close to the car. So I'm trying to specify a refined size close to the car, and then trying to gradually increase that, and I may not have a fine, very fine mesh size far away, like at the 50-meter end of the wind tunnel. I may not have a very small mesh size. It can be, the mesh size there can be somewhere like zero point 0.2 meters. But I do need refinement zones around the car so that the mesh grows gradually. You cannot ever have a sudden jump in CFD runs, because that induces errors, or that's one of the reasons for non-convergence. And boundary layer, as I said, Y plus is one of the it's a measure to see how good your boundary layer is, and it should be ideally less than 10 for cases like these. And boundary layers you definitely need to have on all the parts which are exposed to the flow, but you may not have it, at the inner parts like engine and all these things. So you can control your mesh size by eliminating boundary layers on the inner parts, but you definitely need them on all the outer parts. Then there are a few things about wheel modeling, like how you can have the rotation of the wheels modeled. The first one is really simple. Just have rotating velocity applied to the wheel, but this is a steady state run. And then in the second type is MRF, which stands for multiple reference frame or moving reference frame. And in this, what you do is you add a extra source term to the equations on the right side of the equations and solve them only in the specified zones. So these equations with the source terms will be solved only where you say that these parts are rotating. That is kind of an approximated steady state approximation of a rotating flow. And then there is also sliding mesh, in which wheels are actually rotating. So it's the outer face of the wheel is sliding with that of the car. So it's actually a transient run. Then there's also one more thing you do, like you can model your car as just a half part of the car and have symmetry condition applied. This is one way, a very good way, by like you can have refined mesh only in the one part of your car, and so you're capturing all the details in the car, but also not trying to limit your mesh count. So sometimes this really helps in controlling your mesh count and still having good result. So this is just a summary of the first part. We went over how the external aerodynamics is important to study for all different reasons, cooling and stability or visibility in the car. And then the contribution of drag, which is very significant, and why most of the studies, why they are dedicated to mostly reduce the drag, wind tunnel experiments, and a short overview of CFD runs. So I'm going to switch over to live demo.
Yeah, I do have one question.
Okay.
All right, we do have a couple of questions here, so I'm going to take a moment here so we can go over those, Madhura. So the first one here is the wind tunnels also given a symmetric condition when modeling a car using symmetry. So the question is the wind tunnel given symmetry condition when modeling a car using symmetry?
Yes.
Yeah. Okay. All right. What is the next question is, what is the difference between transient and steady state simulation?
Okay, so in transient run, what happens is you are actually simulating
Thank you. Sorry.
Yeah. So in the transient run, we are actually simulating what happens when the car is placed in the wind tunnel, right from the wind starts blowing. It is so actually the wind is hitting the car and how the flow develops from t equal to 0 to t equal to say 3 seconds. And so when I say transient run, we are simulating, we are getting the result only after what happens after 3 seconds, but it takes 2 days to run it. So you can imagine how much of the physics which goes around. And in steady state run, we are not really, we are getting the results after the car has been placed in the wind tunnel for a while and all the flow has been stabilized. It's been flowing for a while, and then all the conditions around have are stable. And what happens then? Most of the things are kind of they have a particular trend. They show a trend like pressure or velocity at a point will always be constant, or it will have some kind of a trend, specific trend. So that is the main difference between steady and transient. In steady, we are not getting what are actually all the turbulences, or not the turbulence, but all the variations which happen from t equal to 0 to that point, when it becomes all stable.
Oh, thank you. There's no more questions, so if you want to continue on, that'd be great. Thank you again.
Okay. So, for the live demo, I have this model preparation, then CFD. Model preparation will happen mostly in HyperMesh. Then in virtual wind tunnel, where I'll show you how to apply, how to identify different parts in the, like how virtual wind tunnel identifies parts like wheels or heat exchangers, which basically are radiators. And then how you can, for morphing the design, again, I have to go back to HyperMesh. So yeah, let's start with. Okay, so I'm first going to show you how to do surface meshing or wrapping in HyperMesh. So wrapping is meshing the parts, and it may not capture all single detail of that part, but it is one very quick way and in industry. So one part open over here. And you see that I don't really have a great mesh over this. I just have some rough mesh to, I don't need very good mesh for wrapping. I just need some kind of surfaces so it identifies how the wrapping has to go. Now you see over here there are some holes in this CAD. There is this one, this on the blue surface, then there's also one surface missing at the bottom over here, and then also on the side this way. So if I don't have it covered or stitched properly, what's going to happen is the wrapping, while wrapping it, it's going to go inside these parts. So and it's not going to identify the part properly. I'm not sure if everyone really knows what wrapping is. It's just like imagine you are wrapping anything with a paper, going to look. So that is what wrapping does in this mesh. It will identify the outer areas and put a mesh on all the outer areas of that particular part. So I'm quickly going to show you how to patch this hole. So for that, open a hypermesh and make sure over here you have you can change the user profile. So go to engineering solutions and select CFD and be in CFD user profile for this. Okay, so in mesh, if I select hole and gap fill, this is a very good and quick tool to patch things without much efforts. And what I need is I need to select elements and just actually. I have to select patch fill, and then in the node list, if I select a few nodes over here, 1 and 2, then it kind of identifies, make sure it has identified the correct path. If sometimes it doesn't identify, then you can unselect some of those wrong nodes and say proceed and say fill, and it created this patch over here, which looks good, not bad. Similarly, I can go and patch other sides of this. So node list and selecting a node path. Okay. So you see over here it selected some junk things and I don't want it. I want to unselect those nodes. Okay. Okay. Then good. And say fill. Great. You can try, how you can try wrapping without patching it and see for yourself how it looks. Sometimes it does a good job, but it's always, better to patch and do some work on the ground level. Proceed. Yeah. Okay. So I have this mesh over here, and what I'm going to do is going to wrap it now. So I go to mesh again and say adaptive wrapping. And then even in this panel, there are some options to patch the holes, but I've already done it manually. So I'm going to select what elements should be covered in the wrap and just select a block. Proceed. I can say remesh over here and again give some parameters. This looks good for now and say mesh. Okay. And while it takes some time, let me go over okay. So yeah, this is the wrapping and okay. So then there is also one thing called proximity control, which is actually I cannot. Okay. It's over here, proximity control. So what it does is you can, if you do not want to fill some of the gaps and you want to maintain them, like the ones over here, you can tell hypermesh that do not fill these gaps and I want to maintain them. Like if you do not tell that, you do not communicate that information with hypermesh, it will try to jump over the mesh and try to make it, like these jumps you can see over here, red over green. You can avoid that. You can tell it, please maintain it, and it will. That way, you have to specify two components, like this is A and this is B, and then it will also apply some local refinements in the gap and make a smooth, nice mesh in between that gap. So let's see if it has done it. Okay. Okay. So while it meshes, I'll show you how it looks. I already did it once, so yeah. So this is how it's going to look after it's finished wrapping. You can see it has well captured all the important details. It does look good enough. So moving forward, meshing rest of the components in the in your CAD, you can see there's one panel which I use, this auto mesh panel. There are different ways you can access this auto mesh. It's right here. Otherwise, there's also in mesh 2D and auto mesh. So surface deviation is one of the menus I use. There are different menus over here. You can play and see how it behaves. But surface deviation is very helpful for geometries like this. You can specify. It will capture the gradients and mesh it accordingly. Like you can see over here, at all the curvy edges, it tried to have a finer mesh as compared to the rest of the mesh. Also, you can specify the refinement surfaces. I am still waiting for this to finish so I can actually show it to you. Okay.
Now this is a rather large model. Or how long does it normally take on your? Right now you're doing it on your laptop.
Actually, I did it previously, and it didn't take such a long time. Surprised it's taking long right now. Okay, I think it's done. Okay, so if I switch on the CAD and all the So this is the remeshed part, which there is a suffix like wrap and then also a remesh. So what I'm going to do is just going to isolate all these and also change the color. Something looks okay. Okay. So yeah, you can see over here. Probably I had some different sizes right now as when I did it previously, but more or less it looks the same. Okay. Then let's go over the rest of the meshing. Like for example, if I have to do all the meshing, I'm really going to take a long time, but I'll quickly show you this auto mesh panel. In this surface deviation, let me just select a few of the surfaces and then mesh it. Hit the mesh. Yeah, I actually did this yesterday and it didn't take a long time at all.
So we have something that's running. It's taking forever.
Okay, so I have some mesh, and then you can see over here that this mesh is not really closed mesh. I'm not really having a closed airtight mesh over here. So there's one more tool which I can use. It's a Boolean operation. So in this, even you have meshed your parts, you can use them to Boolean it. So I just pick up component 1 and then proceed and then say component 2, which is this side red colored mirror. And then I can hit this local remesh and say run, and it will do the Boolean over the mesh. Okay, so yeah, it did it. So now you can see all the nodes are matching nicely. And if yeah. So this is one easy tool to fix the mesh. And then you can also use this refine button over here, like if I select some of the surfaces and say that, oh, I want to have, I have selected all these surfaces and then say, I want to have refinement over this surface, say this particular surface, specify a different 0.5, a smaller size, say assign, and it will show you this in red color. That's the assigned mesh size, and if you mesh it with a higher number, it will do the refining for this mesh and also the smoothing from refined to the higher mesh size. It will take it gradually, So that's one more good tool to use. So all this meshing can take about, as I said, it may take a long time, but you have to do a good job on this meshing, especially there are these grills over here. You need very nice mesh over them. They are, again, these grids are doing a lot of things in the model. So make sure you have proper mesh over them, or you have any other tiny features at the rear or at the wheels, then yeah. Okay, so let me. Okay, so I have finished my meshing, and then the next step what I do is I go to export. This is my completed model, and I say export and select CFD type, and in the solver type make sure you have Nastran Fluent standard format and hit export. No, I have to select. Okay. And yeah, yes. Alright, so I had some duplicate elements over here. No. Okay. I'm going to go and say check elements. Duplicates. It found 10 duplicates. Say failed. Return. And then go to delete button, which is this shortcut over here. Say retrieve, and then it has retrieved those 10 elements which were detected as duplicates, and say delete. Return. And I again try to hit export. Say yes. Okay, so it exports, and this is how it looks in VWP. You just go to file and find the exported Nastran file. There are different views over here. Like this view will give you, just have to hover your mouse over on different sides, and it will show you what are the different views you can have. So I'll normally keep this.
Excuse me, one question. How long did it take to import the model?
Oh, no, it shouldn't take. It will in like few seconds.
Okay. Yeah. You know, there's many hundreds of thousands of elements. It only takes 3 seconds. Good to know. Excellent.
Yeah. Okay, so moving on, let's go with defining the vent tunnel. So just click it over here and say fit screen, and it's going to show me the default dimensions. But as I said, you really need to have enough proper dimension with just 2% of blockage. So I'm going to say I want it 50 in length, 20 in width, and then 15. And going to, okay, so this is how it looks. Okay, looks good. And then one more thing which I need to make sure, I'm going to say move and go to vent tunnel. So it gives me XYZ coordinates. And then move this at the bottom and get a proper zoom over here. And then make sure move my vent tunnel in Z direction. Okay, so I want vent tunnel to intersect my wheels slightly. Make sure your car is still inside the vent tunnel. Sometimes, your moving all over, and it happens so that the car comes outside your wind tunnel. So just to make sure your car is still inside. So let me hide this wind tunnel now, and then a best way to set up the case in VWT or most of our products is always move from left to right side. So we're done with wind tunnel. Now we are going to identify different parts. Okay, so if I hover my mouse over this, it will show me identify wheels. So I'm going to click that and click the rims and the wheels. So this is my tire 1. Oops, and I selected a wrong thing. And I have to, why is it not deselect? Okay, so deselected it and go to the second wheel. This is my other wheel. And okay, and you can see it has also identified the rotation direction of the wheels. It's based on the wind direction. So and you see over here too, it changed the icon over here. And if I click on the rim, it will show me that this rim belongs to wheel 1, and then there is tire which belongs to wheel 2. So it has identified rim and tires, and then put them in wheel 1, wheel 2, wheel 3, wheel 4. The next thing will be identifying heat exchangers, which is the radiator. So what I'm going to do is I'm going to just hide all of the things, and all these parts I'm going to switch on, which mainly make up, or you can select, right click and say isolate, it will show up. Say isolate, okay. Oh, come on. Anyways. Okay, I want to make sure I'm still in the right direction. So identifying heat exchanger. Okay. So I go here, and then the first thing I have to do is select inlet. You can see this in over here is highlighted. So select the inlets, is this and this one, and then the next thing is to select the outlets. Oops. Okay, and then go over here outs and see this is my outlet and this is my outlet. So when I specify inlet, which is blue, and the red is outlet, the remaining thing it will specify it as, it will automatically detect that rest of the things are the frame. So you see here again the icon of all the heat exchanger elements have changed from the default to the special thing. Okay, then what you can do is there is this small icon for almost all of these options over here, and if you click it, it gives you a nice summary of all the parts in it. What are they identified as, and then you can also select on which of them you want to have or you don't want to have. Like if some of these things are really in the interior, then you can uncheck this boundary layer. So you have your mesh size is not blowing up. Okay, we have identified all the parts. Let me switch on all the CAD or mesh. Now, this is the refinement zone. You can build as many refinement zones as you want. So if I just click one, there are by default 3 already defined, and then if I go to this tabular form again, I can specify these are the default sizes of element sizes, but you can definitely change them. You can also change the size of refinement zone. If I click this and like you see that it will show you the direction, and just drag your sides to whatever lengths you want. Similarly, you can do this, or you can hide some of the zones, or make them even if you have defined and you don't want them, you can uncheck this button over here so it becomes inactive. So it's defined, but it's not going to be effective. Then also, if you want a special zone around, especially around some special parts like the upper body or the wheels, I can specify that I want it around this wheel, and then just so this is the view I want, and easily drag this face. Somehow it's not picking it up. Okay, so I can just change I showed you how to change, but somehow it's not picking the right face over here. Oh, I know why. I was not in the right option. So, okay. So you can change this this drag. Make sure you're clicking this edit zone and then clicking, the boundaries. So, yeah. So you can stretch this side as much as you want, and so that it covers both of the wheels together. And again, specify different refined mesh size over here. Then the next thing you go is section cuts. So section cuts and the next all these options like section cut as well as the pro points are defined so that you get the results on all these sections or all the points. And at the end of the VWT simulation, you get an automated report with all the contours, and you can choose which contours you want it to plot. So so let me first create the cut section. So this is my one cut section, and then this blue shaded section is what it is right now showing your cut is. So I can still add as many as I want. If I want it in different directions, just switch that and make switch on to the locations. You can also have the exact location depending on this, XYZ over here. Put in the coordinates and change the location of the section cuts. And if I open this table again, then I can, it gives you results, all these different results: velocity, components, AD, viscosity, pressure, velocity. And you can, if you don't want all these results, you can uncheck them and select what you want to have it outputted. Yeah.
So can you rename the section cut names?
Yeah, sure, you can do that. Yeah, over here, rename. You can rename anything, even the zones. Then similarly, you can create probe points. Just click this, and if I say, if I especially want to see how, the eddies, they happen around this mirror part, I click here. I can also move it, or again set, if you know the exact coordinates in your CAD, then enter the coordinates and you are all set. And all these things which I've generated, you can see it in the side tree diagram: refinement zones, probe points, section cuts. You can directly delete it from here. If you say isolate, it's going to only show you that particular thing. Where is it? Yeah.
Another question from a little earlier. Is it necessary to model the heat exchangers exactly like modeling the fins or tubes?
No, I don't. I mean, not really. I mean, in this heat exchanger which we have right now, it's not really modeled. It's just the outer size of the radiator, So, ultimately, this will be modeled as a porous media in the CFD run. So, but you just need to identify which is the flow direction over here. So it may not be the exact tubes and the things. Even here, I don't have it. I just have the outer part, outer size of the radiator over here.
So it really depends on where you want to focus your analysis on. So if you really want to fine-tune around the heat exchanger, that your model should be done for that, I would say. Okay. Yeah. So in a large model like this, you probably want to go for the detailed results of the heat exchanger. Okay.
Right.
Yeah. A couple more questions came up. The next one was, in virtual wind tunnel, for different load cases such as wind speed or angle of attack, can I submit calculations in software only once to get all the results? So again, so in virtual wind tunnel, for different load cases such as wind speed or angle of attack, can I submit for these calculations basically to happen all at once?
I didn't get it. Can you repeat it again?
Okay. Well, I'll read it exactly. And so for different load cases, such as wind speed, can I submit the calculations in, again, virtual wind tunnel only once to get all the results at once?
You can do that using hyperstudy. Because you're saying you want to change the wind speed at every time. So it's part of a hyperstudy where you can specify. In hyperstudy you can not only do different velocities but also different design changes. So if you have different kinds of designs, like adding a rear wing or extra flutter and I don't know, whatever you want, create different models and then club VWT with hyperstudy and also supply it with all the models. You can do everything in one run. Then it will tell you which is the best design, or it will tell you can tell hyperstudy which conditions to monitor, like which variables you want to monitor. Like in this case, it will be drag. So.
And I believe in that case there's a tutorial going over how to use, and that might be AccuSolve, or is it actual virtual wind tunnel and HyperStudy?
I think for the tutorial we have it with AccuSolve and HyperStudy, but it shouldn't be that different with VWT.
And the wind tunnels, there was a question about wind tunnels, for tutorials for virtual wind tunnel. And depending on how you registered, so if you are registered on our user portal, you have access to all the tutorials that come with the software online, so you can go in there, find what tutorials match what you want, and then be able to utilize them. If you have not registered on our portal, but are only registered via the student, and I'll show how that is. There's a smaller set of learning material there for students, but for the complete set you would have to register. on our web portal, and I can show that in a little bit later. But it also expects that you've done a full installation of the software because it will tell you where all the models are located for that tutorial, which comes in with the full installation. You can download most of them separately, but it's, again, it's much quicker if you have them with the full installation.
Okay, so so we have put in the section cuts and probe points. Next thing over here is material. By default, we do have air and water, but you can also define your own materials. And then hit this run. So run has all some of the mesh setup over here. Like you can also decide, like, give the wind speed over here. By default, I think it is 50, and that's why when you load in your wind tunnel, you can see this 50 meters per second and the direction of the wind. Then you can decide over here if you want a transient or a steady state run. Run time, as I said, usually is about 3 seconds, and the time step can be like this small, like 0.001 or even smaller than this. So you see, when you finish 100 time steps is when you are going to get a solution after 1 second. And those 100, the time taken for that 100 time steps depends on how many cores you're using and what is the mesh size. So you know, you need to it's every time while doing any these kind of runs, it's important to have like a right balance between capturing all your features and also keeping your mesh count in check. And then select your material over here. If you have a material like of your own, it will again appear in this list, like here, material 1. Decide if you want to have a moving ground, rotating wheels. All these things can be set up over here. Then the first layer height of the boundary layer can also, like, this is a bit bigger, but I'll usually go with like 5e minus 5, and at least have like 5 boundary layers. At least 5 are definitely, I mean, I usually keep it like 10, but yeah, 5 is something you definitely need. And then the gradual increase from boundary layer to the outer mesh size will be done automatically in the volume meshing. So all this is that is all setup required in virtual wind tunnel, and you can next what you can do is hit run. When you hit run, it's first going to start volume meshing it, and when it finishes volume meshing, at the background it will start AccuSolve. So AccuSolve will be fired up, and all the CFD run will happen in AccuSolve. So VWT is, you know, actually just customized GUI for car kind of models, you know, running. It's just a different GUI for a special industry, but at the background it's running AccuSolve. So I already ran this case, and I think on 48 cores it took about 10 or 12 hours probably to run this. And at the end I said it creates this VWT PDF report, and this is how the report looks. Okay. Yeah, so it will give you all these details, like, you know, mesh, simulation time, what kind of simulation it was. Drag and lift are automatically calculated over here. Then element count of the volume mesh size. dimensions and all these pictures, it will automatically generate at different section cuts which you have defined. So, all these that it has also calculated drag on each and every component.
And that's by default. It's given.
Yeah, it's by default, and all these contours, whichever you asked for, streamlines, and I think the plot which we saw at the top was for the pro points. Okay, so yeah, this is mainly the VWT part, and as I said, you can also do some morphing. So morphing is a quick design changes to your model. I'll play this nice video over here, which is done in HyperMesh. So you can create these red dots are called handles, and you can generate these handles and just move them along XYZ, or if you have the coordinates, you can also move it to a particular coordinate, change your design, have the model ready, and again export it as a Nastran file. You don't need to mesh it again. Everything is automatically taken care of mesh, of all the surface mesh. Just again get it back into VWT, and you don't really need to do anything because you already set up a case. So let me show you. So for example, if I go back to VWT and say that I have one more morphed design, then I go here and say import desktop. Maybe I'm going to right now import the same file just to show you. Okay, so you see here it again imported the second model, and say delete over here. See import. What else? Okay.
You don't need to delete the first model.
So I'm sorry, the first model was the earlier model was at a different scale, so it showed me something very big. So now I have these two models over each other, and I can delete the first one, and since I have the same, approximately the same dimensions, I don't need to do anything other than just identifying the parts, and most of the refinement zones which I had defined earlier are going to match because the car was at same position. So when we bring in the models, and when you are constructing a wind tunnel around it, it's always good to change the position of your wind tunnel. So if in the future you are having any design changes, you don't have to redo all those setting up wind tunnel and refinement zones again and again. You already have it. You just get in the model and hit run button. So that's one good thing. Also, I'll show you one more. Is this export option over here? So, like This model, I probably may not run it on my own laptop, and if I run it, then I'm not going to be able to do any other things. So most of the times I put it on cluster or other supercomputer kind of machines. So in that case, if I hit export, what I get is a .vpar file and .nastran file. So get these two files on your cluster, and then fire VWT on your cluster machine. So from there, it will again start. It will have the mesh in the nastran file and all the VWT settings in the vpar file, and it's going to use that information to start meshing and then directly start a AccuSolve run from there. And it will also generate a report. So that's one good thing. Most of the times I use export option rather than hitting run on my own machine. And let me quickly show you morphing. So morphing is, if you go to hypermorph, there are a lot of options over here, but I'll show you some quick ones right now. So go to morph volumes and say create. Select the elements around which you want morph volume to the morph volume to build. So okay, so this is one block, and what this suggests is like all these all the elements under this green morph volume can be changed with the handles which I have over here. I want to change the size of the handle. It's too big. Okay. And I can split this into different components, into still different sizes, and the splitting option is very quick and easy. I just place the cursor over here. Now this number over here is actually giving you fraction of this edge, the highlighted edge. So I can change it from 0.5 to 0.8 or maybe 0.7 and say split, and it will cut the volume and create two more handles at that level. And then let me do it at this 8.5, say split, and one more in Y direction, split. Okay, so now what I can do is just change the shape. If I want this to, so go to morph over here, select the handle which you want to change, which you want to move, and you're going to see this tripod. Just hold it, highlight one of the axes, and start dragging it. What is wrong? Yeah. So when you keep dragging, it will show you how the design changes. Or what you can do is, right now I'm this interactive mode. I can also have, okay, I can also have move to XYZ or move to a point, and then if you know what are the coordinates, then you can put in the coordinates and say morph. So I'm just going to say morph. Return. And then export this model. So you can do a lot of changes, like you have like this video shows it over here very nicely. They change the shape of the car, raise the hood a bit, raise the upper body shape a bit. Okay. So the next thing I was talking about hyperstudy. So in hyperstudy, you can do different kinds of optimization studies. Like over here, they have done it for Flutter, and you see that there are different kinds, like a straight one and the one with sinusoidal wave, and they had 3 different designs. They clubbed it with hyperstudy, and then it gave in, and then drag and the downforce were the two parameters which were asked to monitor for hyperstudy, and this is the graph it gave it out. So it is very useful tool. Another study which we did was this exhaust. There was a pipe just below, not an exhaust pipe, this is at the front end of the car, just to help the cooling of the brakes. So you see there were 3 different designs. Over here, the bulge is on the upper, it's going up and down. It's in this, it's going sideways, and then over here we are increasing the diameter of the tube. And then on the clubbing it with hyperstudy, we saw that it gave the optimized design gave us 120% higher mass flux, which means the initial design was really not good. And the one with the first design, where the bend was on the upper side, it gave a more optimized design. And you see over here how for the first straight design, it's a stagnant flow over here in the front area of the brakes, and it's and that is resolved better if I have some twist or some curvature to this pipe. So you see this eddies over here, they're stuck over here in front of the brakes, and that's why the cooling was not as effective.
So question is, can you do the viewing of these results in virtual wind tunnel, or this has to be done in a different tool? Because you get a report from virtual wind tunnel, but can you actually look at the streamlines actively moving as we're seeing here?
No, you cannot do that in virtual wind tunnel. We have 2 different products for that. There is hyperstudy, and then there is also AccuFieldView for processing AccuSolve results. Now, FieldView is actually a commercial product, but AccuFieldView is something which FieldView is customized to read only AccuSolve results or VWT results. So you can read them in AccuFieldView and do all these. So all these animations are from AccuFieldView.
And is that results file plot given to you so you can access it in FieldView?
Yeah, you can read the results in AccuFieldView and even get additional sectional cuts.
Okay.
No, other than defined in VWT.
I guess the main thing trying to figure out is, does anything additional need to be done to use FieldView? And its answer is no.
No.
Okay.
No. Yeah, actually, that is all I have for today. And then, did I miss anything? I don't think so.
Okay, so, and we do have another question.
Mm-hmm.
Can we export aerodynamic load, for example, pressure, to hypermesh in order to analyze the related structure?
Can you repeat it again?
Can you export an aerodynamic load, so in results from virtual wind tunnel / AccuSolve, can that load be read into hypermesh to analyze?
Like the structural loads, you mean?
It's a pressure load. No,
So if you have some structural loads or something, then that may be possible if you're doing like a FSI kind of run, because in that you need structural as well as fluid collaborate together. So if in some of the options in VWT, if you saw this is like this flexible over here. So if it's a FSI run in VWT, which you can do it, I haven't done it, but I'm sure then you do need structural load file or OP2 file.
Okay. So I guess we need a little bit more detailed definition of what's looking here by the person asking the question. But we can also take that offline for that question there. So so this way the user knows or the asker of this question can send us your contact information in the chat window. We can note that and contact you later, so we can figure out better what you're trying to do there. Because I'm not sure if it's an FSI question.
Yep.
All right. So do you want to see if there's any additional questions, Madhura, or is there some additional information you want to show?
I don't think so. I have missed anything.
Okay. No, I think you got everything. And actually, I just noticed we are actually at 1:30, which was the time frame. Nailed it. So that'll give like 1 minute to cover the other details. So let me do that right now. So I'm going to change myself to the presenter. And thank you so much, Madhura. And if people do have additional questions, please let us know that we have our support form on the academia site, and I'll show that. That way, our individuals who are helping out with all the EDUs, they'll take the lead on it, and if they can't answer the questions, they'll pull in the specialist from the local office, since we do know that some of individuals here are not based in U.S. like we are, but we do have specialists in the different countries across the globe. So if they, they'll make sure you get it to a person in a close time zone for those type of questions if you can't answer it. So let me again. So again, thank you so much for her and for this overview of virtual wind tunnel and aerodynamics, why people would want to do it, and showing how to apply that with virtual wind tunnel and the reports given. So there's a lot of information here. And so we'll try to show what some of these tutorials are too. And I appreciate everybody if they can stay on for about 5 more minutes, and I'll cover that at this point. So, all right, so let me now show my screen.
You are.
All right, thank you. So what I'd like to do here is, so first thing is, how do you get access to our software? Every competitive team out there, Altair would like to help out and sponsor them with the full featured version that allow you to run on your own lab machines, your own cluster for your competitive team. Or if you're just a student and have an exciting final design project, senior project that you would like to work on, you can download a free student version, which is a limited version, but it still allows you to do, reuse our products. The only thing about the student version is it doesn't come with virtual wind tunnel, because as you can tell, doing CFD analysis requires quite a few elements. Like the model you had there, I think had 27 million elements in it, so that was pretty large model. The limit is currently 10,000 on the student version. So as you can tell, but for any competitive teams, you would get the full featured version that does not have any limitations. So if you go to our website and go to the academia tab, you'll see a few different additional tabs here. So first, if you want to get the software, you can go in here, ask for the free student version. You get a year-long license. If you would like to, for your competitive team, you can go to the sponsorship overview, read that, and then go to the sponsorship form, fill that out. We'll get it, and we'll contact you of how to get your license. Again, we'll get the local office there to work with you on that. The main requirement on the sponsorship form is that Altair is mentioned in any documentation, and we will send you a few stickers to put on your vehicle, so that they're placed on there too. So that's the main commitment to get the free full version of the software. Also here we have the learning library. And if you go in the learning library, this is different forms of material in here that you can find out. And right now I think it's set based on what's been put on most recently. So it shows case studies and things like that on here too, if you want to see how people have used it differently. But if you want to look at, in this case, maybe some training videos. We know that for students, we have more training videos than actual tutorials. That seems to be something the students like a little bit more. And so you can find different things on here about that. If you want to, narrow it down to something else, a different area, like for instance, you would like to see things about pre-processing model setup. In this case, I probably have to reset this, but there's additional things about doing the pre-setup here. You can also, get certain books we have. They're PDFs that you can download. You just have to fill out your contact information, and you can download some books about practical aspects of finite element analysis, doing structural optimization, multi-body simulation, and crash analysis too. So some very handy books there. We also, as you can see, there have some additional books that you can get access to, electromagnetics and so forth. So that's how you can get access to some of the different training material that way. But if you want the larger version of our training material, if you go to our support page, go to our client center, and indicate you would like, and I'm already logged into it, but you would like to go to the online help. We have two different forms currently. You'd want to use the Altair Connect. That's our new web portal. And just going in here, you'd say documentation. And since Madhura was talking about virtual wind tunnel, let's go to virtual wind tunnel tutorials. And it will indicate here's in the user manual, there's a virtual wind tunnel. There's some other, again, just like with any of the tools, you can nail down what's being shown here. But this probably is the good first one to go to, and you can then open that up. So that's how you can find some more information there with tutorials on the website. But there is, so again, if you are part of Formula SE team and you've already signed up to be at the Formula SE this May at Brooklyn, Michigan, we do have a award there called the Bill Adam Award. And if you go over here under competition, go to the awards, you'll be able to review what the award's about. And if you want to register for it, just click on the link below and you can apply for it. You need to be present to win because the judges will be coming around to each of the vehicles that have registered for it and be reviewing what was done on the vehicle. So those were the main points. Again, Altair would wants to make sure all the competitive teams can have access to the software. Many universities already have access to software too, and sometimes you can use it in the the computer-aided engineering labs there at your university. So that's one way to get access to it. But again, you would be accessing licenses, limited amount of licenses by the EDU. When dealing with teams, it seems like they'd like to get their own license, so that way if they want to have their own designated workstations, they can do that. Or if they have a larger workstation with, let's say, 64 cores and they want to just run it on that, they can do that usually more easily, having their own license. So if you do have questions about using our products, you can contact any of our local offices support team. Let them know the situation that you want to know more about how to use the software, and they'll direct you to the person in their office that will that handles those type of inquiries. So great, thank you so much for taking out the time out of your busy schedule, and again, contact us if you do have more questions. And this link to this webinar will be posted usually within 24 hours, and each one of you will get an email with that link to it. Again, thank you so much, and good luck with your project or your competition.